Hello world, welcome back to another tutorial. Today we're going to be talking about how to apply textures or images to meshes. This means we're going to be talking about textures, we're going to be talking about samplers, and we're going to be talking about texture loaders. Get pumped. It's going to be a pretty good episode. We're basically just going to take what we learned in the last episode about texture coordinates and now apply that to adding textures to meshes. If you like this video, go ahead and like it. Hit that little thumbs up button. If you want to subscribe and just keep getting this content over and over and over again, feel free to subscribe. And if you want to hit me up on Discord and chat about coding, because I like talking about coding and games and stuff like that, hit me up in Discord. Let's go. All right, so the goal of this episode is to get this texture onto this mesh. So the mesh is made up of 4 different vertices, and each vertex has texture coordinates applied to it. And we know that there are UV coordinates for the texture. So if we just match those up, boom, we have a mesh with a texture on it. Now, before we dive into exactly how that works, I want to talk a little bit about how the memory is shared between our fragment shader and the CPU, okay? Because the CPU and GPU do not talk directly. It's not like a direct communication. Basically, there's a broker with memory state right in the middle of the two. And the CPU will call set fragment buffer at these different locations. So set fragment buffer with these bytes at this buffer location, and the GPU can now go in and access that. So in this case, we have a material type. So we know it's of material size to grab from buffer at 0. As you can see with the attribute with the 2 square brackets, buffer at 0. That is how we are accessing that memory at the memory state for the fragment shader. This also works for the vertex shader. And then we do that with textures. In this case, in this episode, we're going to be passing textures. So we're going to set textures at 0, 1, and whatever. And we will need to access that like this. Samplers, exactly the same thing. So this is how the CPU and the GPU communicate memory changes. So the shared fragment memory state, we can read or write to it based on the settings we pass in when we say set fragment buffer at 0. This buffer has read and write capabilities, and then in the GPU we can either read or write from that location. Let's go back into some textures. So right here we have this really simple 2D texture with these UV coordinates, with the top left being the origin, and then it goes to 1, 1, like we talked about in the last episode. You know what's up. And we want to take this and we want to apply it to this triangle with these UV coordinates. And what we'll end up with is this cookie cut it out triangle with the same exact colors. So how the hell do we do that? Well, when you're doing sampling in metal, we're going to pass a texture into the fragment shader, and then also from the fragment shader, we're passing in the vertex out information from our vertex shader, and we have our primitive fragments that are uncolored. They're not colored in. And I talk about this in my vertex fragment shader episode, so if you want to go check that out, that's going to be pretty useful for you. But basically what's happened is we have these interpolated texture coordinates now inside of our fragment shader. So what we're going to do is we're going to use a sampler. And what the sampler is going to do is it's going to sample at texture coordinates different colors. So in this case, at this texture coordinate that we've passed through from the vertex shader, we're going to sample our texture there, and we're going to get red, and it's going to color in that fragment red. And then we're going to keep going down through and sample for each one of our fragments. We're going to grab that color with that texture coordinate applied to it. And then we're going to do that until we've filled up all of our fragments. And then once we have all our fragments colored in, we should get this really nice cookie cut it out triangle from that texture. Now, we can't talk about sampling unless we're going to talk about minification and magnification. So minification is going to be when your mesh gets smaller, how do we interpolate color? Magnification is going to be the exact opposite. As your mesh gets bigger, how does it fill in those little creases of colors? Because I know for a fact that this is like a 512 by 512 image, and this is a lot bigger than 512 by 512 on my screen. How does it fill in those different colors? If you take the party parrot on the left and the party parrot on the right, each one has a different filter applied to it. And if I zoom in on their beaks, you'll notice that the one on the left is a little blurrier and the one on the right is more sharp. Now that's because the one on the left is using a linear filter and the one on the right is using nearest filtering. Now these are different algorithms created by smarter people than I. I did not write these. You just basically say sampler.min filter is going to be linear. this is going to be the difference in what your texture looks like when it's finally outputted onto your screen. You can change it based on what effect you want. You can find out more information about that in the documentation. I'll put that link in the description, but that's basically going to give you the min filter, mag filter information, and all sorts of other stuff you can add to your samplers. So enough talking. Let's jump into some code because I am pumped. All right, so back in the code, the fun stuff. We had this output from our last episode where we created our texture coordinates and we created this cool little wave broken TV type deal. Yeah, this is our output. Let's, instead of this, let's apply a texture. So I'm gonna close out of this. I'm gonna go ahead and first go into my core folder, create a new group, and I'm gonna call that group res for resources. So all the resources that we'll need to pull in, we'll put it in the res folder. And I'm gonna put that right here at the top. So our res folder, the first thing we're gonna put in this res folder is going to be a party pirate parrot, okay? So make sure you have these guys checked, and boom, we have our pirate party parrot. He looks gorgeous, doesn't he? And this is the guy we're gonna be applying to our quad. So moving forward, let's go ahead and close core for now and go back into our graphics, shaders. We're going to go into basic shaders. We're going to start into basic shaders. And I need to delete this code. So I'm going to delete from color to game time. We need our texture coordinates still. And I'm going to uncomment out this code real quick and move this up and build, and it should work just fine. Yep, everything's happy. We're not using our texture coordinates anymore. All right, so first thing I want to do is I want to turn this. So I'm going to add another condition, and if we add conditions in this, it'll look really ugly. So the first thing I want to do is I want to break that out into a actual if statement. So give me 1 second. Okay, so now that we have this dude built out, now it's not a ternary operator, it's a couple of these, you know, it's an if-else statement. I want to add one different if statement, and that is going to be if material.use texture. Now we haven't actually put that there. I'll do that in just a second. But now if we do use texture, then we want to apply texture color here. Else, if we are using material color, we're going to use the material color. Else, if we don't do any of that, we're going to use the vertex color. So let's figure out how to apply texture color. First thing I'm going to do, though, before I do any of that, is we need to create this variable on material. So if I go back into my little shaders folder and go to shared.metal, at the bottom we have struct material. Just go ahead and add the boolean of use texture here, and that's going to be just fine. So now the material on our GPU side has a texture, but our CPU doesn't. So I'm going to go back to our core. I'm going to go into types, metal types, scroll down to the bottom where we have material, and I'm going to say var use texture as a boolean, and I'm going to set that equal to false. Now I'm doing that because I don't want to forget it, and we're passing types through, so we want to make sure it's the same size on the other end. And yeah, so now we have material.use texture. It builds just fine. Let's figure out how to use these texture coordinates on textures. So first thing I'll do is I will pass in a couple parameters. First one is sampler. So I'm going to call that, the type is going to be a sampler. I'm going to call it with the variable name sampler2D, and then I'm going to set that at the sampler location of 0. Now, the next one we'll need, so we have a sampler, next thing we need is a texture. So this will be a texture 2D, and that will take in float as the type. So when we're doing the sampling, we want to sample float values, so we get a float 4. If we put half here, half right there, then this would need to be a half 4, because that's the type we're going to be pulling from when we sample. So this will be a float, and we will put that as texture, and this will be at texture location 0. Now if you notice, sampler is set at 0 and texture is set at 0, but these are two different memory blocks, okay? Texture is a different type of memory, and so it's going to be stored in its own location. Sampler is going to be stored in its own location type. So we can actually set these both to 0, and it's going to be in different locations in our memory, and we covered memory in the description. If you skipped it, go watch that. That part's pretty cool. But yeah, now we have a sampler, we have a texture. Let's grab the color from our texture using our sampler. So if we're using our texture, we want our color to equal texture.sample at or well, we're going to say texture, start with the texture. We're going to sample it, and we want to sample using our sample 2D, sampler 2D, at the texture coordinates. Text chord. So we're going to sample our texture using the sampler 2D at the texture coordinate that's been rasterized and interpolated across vertices. Let's move on to CPU. So first place I'm going to start, I'm going to close up this graphics. I'm going to go into entities and open up libraries. So we want to pass textures through here, right? So we have textures coming in as texture 2Ds. We want to be able to pass a texture. Well, there's a certain type called the MTL texture that we will be sending through to the GPU. So we need to generate those textures. So we'll need a library to store these textures in that we can load up from the very beginning and then access them as we wish. So I'm going to create a new library right here. I'm going to go new file under libraries. It's going to be a Swift file, and I'm going to call it texture library. All right, so now we have texture library here, and I'm going to go ahead and implement this, and I'll be right back. Okay, so I've created all this code. It looks beautiful. Basically, it's just a library like we've covered in all the other episodes. It's going to have the type of texture types. So as we add textures, we'll just create a new texture type that we can access, and it's going to return an MTL texture that we can pass up to the GPU. All right, so we have our fill library function that will fill up in just a second. And yes, gorgeous. The type that it's storing in the library that it's grabbing the texture from is a texture, and that is right down here. So class texture, all it has is the property texture, and the whole idea of the texture class is to build up this texture using, simpler terms. So in this case, our initializer takes in a texture name. So over here we have Party Pirate Parrot. That's going to be the texture's name. The extension, it's going to be defaulted to .png because that's the majority of our textures, but we can also change that if we really wanted to. And then the origin is going to be top left default. I've created my own custom texture origin enumeration, which you see right here, but that's going to be defaulted to top left. We can also do bottom left, and there's a reason for that I created a custom one. I'll show you that in just a moment. So the initializer, here's the parameters. We create this texture loader class that I have down here. Talk about it. So we create a texture loader. We pass in the texture name, the extension, and the origin. And then we create our texture as an MTL texture. And we do that by calling texture loader.load texture from bundle. So all of these things over here, our bundle. These are So we're going to load the texture from our bundle. And then we're going to set the texture to whatever texture we return. And that'll be right here. And then we return it out there. So let's talk about our texture loader. Like I said, I created my own texture origin enumeration because, let's just scroll down just a little bit. You'll see that the other one is mtk texture loader.origin.top left. I didn't want to type that whole thing. I mean, I didn't want to. So basically, I just passed in this guy, top left, and it will set that. So yeah, we hold our texture name, our texture origin, and our extension in our texture loader class. The initializer goes through and it sets those guys, and then load texture from bundle is all the work being done. First thing we do is we grab the URL for our bundle. So it's going to grab that URL, and then we're going to create a new MTK texture loader type using our device. We're going to set the origin as the origin option, MTK loader option origin, and then down here in our do try catch, we're going to say texture loader dot new texture, like new MTL texture, using the URL from our bundle with the options of basically top left in this case, and then we're going to set the texture name right there. So this right here is all the work done where we load the texture from bundle. Like I said, you can do it differently if you really like to. This is how I did it. But yeah. So now we have the ability to load a texture up into our class. So let's just do the first one. So I can say library.update value. The value is going to be a texture. And you see we have these two different initializer. The only one I really need is texture name because it's a PNG. The texture name is going to be Party Pirate Parrot. So I'll just go in here. I'm going to copy that value and go back and say texture with the texture name of Party Pirate Parrot For key, well, we need a case party Parrot, and I'm going to say dot party Parrot. And yeah, now we can grab from our texture library the party Parrot image. Yeah, but we're not totally done with this library yet. We will need to go into entities class and add it. So I'm going to copy this mesh library one and basically do the same thing. One moment. Now we're using a texture library, and I need to initialize the texture library down here in the initialize function, texture library, and boom, we can grab textures using the entities class now. So we have our texture being able to be grabbed. Now what we need is our samplers. So get out of entities. Let's get out of there. Let's go into graphics, go into libraries. Let's create one more library. The library is going to be a sampler state library. So new file, sampler state library. And I'm going to go ahead and implement the sampler state library. This one will be a little bit easier than the last one. So one second. Okay, done creating the sampler state library. Just another library. Creating libraries all over the place. But this one's going to be very simple. All it stores is sampler state type. We don't have any of those yet. And it's going to return the MTL sampler state to be passed to the GPU. The sampler state class or protocol that it's going to be holding is going to be just basically have a name and a sampler state attached to it. And then the class that I've created so far is a linear sampler state. And the reason I call it linear sampler state for this class is because I pass in through the initializer. I say the min filter, we talked about this in the description, is going to be linear, and the mag filter is going to be linear as well. You can also do nearest here, but I don't want that. I want them both to be linear. And then I set the label name, and then I use the device to make a sampler state. And boom, that library is a lot easier. Basically, we're just creating sampler states. So what I'm going to do is I'm going to go library.update value. The sampler state is going to be linear sampler state. For key, we don't have one of those yet, so I'm going to just create a case up here and call it linear. For key, and it will be .linear. Boom! Sampler state library generated. I'm going to put that, that's good right there. Let's go into the graphics class under graphics, and let's add the sampler state library. And give me one moment to do that. All right, so I just copied this one up on top, pasted it, and then I replaced all of them with the ones that we want. So now we have the sampler states. I need to initialize that right here. Sampler state library equals sampler state library. And boom, we now have a way to access our sampler state library using graphics. All right, we are just about done and ready to show some cool stuff. So I'm gonna close graphics. We have entities and graphics taken care of. We have our samplers and our textures. Let's use them. Let's send them to the GPU. Woo! So let's go into game shiz. I'm gonna go into game objects, and we're gonna just do it for our game object class. All right. So right now for our material properties, we have a way to set color, but we don't have a way to set our texture. Okay. So I'm gonna go up here. I'm gonna go private var. Let's call it underscore texture type. We don't want to store an MTL texture here because that means we're storing it in two places, unless you want to store it a non-singleton value, which means it won't get updated everywhere else. But in our case, we don't care. So I'm going to store texture types up top, and that will be defaulted to .none. So texture types .none. It won't be one. Maybe. And yeah, so now we have texture type equals texture type.none. And when we initialize our game object, we need a way to set our texture, which would be down here. So public func set texture. Set texture will take in a texture type. We will say self.material.use texture equals true. We will say self.material.use material color equals false now. And then in set color, we will also, let me just add that, self.material.use texture equals false. And we need to do the basic thing of saying self dot texture type equals texture type. So now we have a way to set our texture. One thing that's mandatory that we pass through is our sampler state. So right here in our do render for our game object, I'm gonna go render command encoder dot set sampler state. And this will be in the fragment. So set fragment sampler state. We will set it to graphics dot sampler states at dot, well, let's do linear because that's the only one we have, and then this will be at index 0. Remember, we're setting it to sampler at 0, so this will be the index of 0 as well. And then down here in our fragment shader, actually let's add this down in our fragment shader because that makes perfect sense. We will say render command encoder dot set fragment texture. Now, what texture do we want? Well, we want our entities dot textures at dot, well, we have our party pirate parrot. Want to set that texture at index 0. Okay, so now we're setting our sampler state and our texture, but we only want to set our texture if material dot use texture. Okay, so if we're using our texture, we want to set it. If we're not, well, we don't even want to take that step and add it because we don't need it. We're going to use the material color or the vertex color. And that's it. If I press play, I don't know what's going to happen. We're going to find out in just a second. Let's see. Not working. Of course it's not. One moment. Oh my gosh, the reason it's not working is because we haven't even set the texture. So technically it's working. So let's close game objects, go back into our scenes, go to our sandbox scene where we are creating this quad. See that quad? Before we add the child quad, let's just go quad.set texture to dot party pirate parrot. Let's go back into game objects. Go to game object, and instead of setting party pirate parrot, we need to set this to texture type. Duh, we created that texture type for a reason. I bet a couple of you smart people caught that. But now we're setting it to texture type, which we're setting when we call set texture, and we can now set it outside, which will set it to true. And yeah, let's see if this works. Woo! Okay, so we have our party pirate parrot working. As you can see, the color's off, and I'll talk about that in a second. But yeah, we have this freaking party parrot on here wrapped around our mesh, and we can do with that what we please. Now the color, what the hell is wrong with the color? If we go into our core preferences and we go to the pixel format, right now we're using BGRA8 UNorm. Instead of using UNorm, we can go sRGB. The reason for that, the color distortion is because of something called, sorry, I forgot what it was for a second, but it's gamma correction. So basically, you can look up gamma correction and how to fix it if you want. There's other ways to fix it. We can fix it directly in our shader. We're not going to do that because that would take too much time. But we might, if you guys want me to show you how to fix it, gamma correction, I can. Just let me know in the comments. But basically, we're going to set it to sRGB, and that's going to fix that gamma issue. And we should see a nice, pretty pirate party parrot. There he is in all his glory. We could even go and do something like in our sandbox scene, we can on update or do update, we can say quad dot rotate y game time dot delta time, and now we have a rotating quad with our texture on it. Let's see it. Boom. And you see he draws in the back exactly the same direction, and this has to do with, or in the opposite direction, that's just the UV coordinates flipped. So, as you can see, we are now applying textures to meshes. Hope you guys enjoyed this video. If you liked it, please like it. Didn't like it, go ahead, thumbs down it, sure, why not? Let me know. Or subscribe, and I'll put out more and more content. So, thanks for watching. See you later.